first one, what kind is the first one?
Exponential.
Quadratic, then linear.
Yeah, then quadratic,
You take it too far.
and then linear. So linear is always going to be a straight line. Quadratic is always going to like be that U shape, so it's going to go up and then back down, or down and then back up. And then exponential like increases or decreases on one side and flattens out on the other. Okay? All right, for this, it's absolute value of x. This is the parent function for it. So what's the absolute value of negative 3? 3. What about negative 2?
2.
Negative 1? 0? 1? 2? 3? Yep. So it basically starts at the origin, and then it goes up 1 over 1 in both directions to create that V shape. Like this. Any questions? Okay, so today is all about just looking at these 3 types of functions that we've done this year and kind of comparing them and deciding like what set of points or table is going to be what type of function, okay? So your objective is students will be able to choose a linear, quadratic, or exponential model for data and graph absolute value functions. Right, so just a reminder of what these equations look like. Linear is y equals mx plus b. What is n? Yep, the slope. And then what's b? The y-intercept, yeah. For quadratic, it's ax squared plus bx plus c. We have not learned how to like compose those equations necessarily, like how to come up with what the equation is. I'm going to kind of show you today. It's not that difficult. I just learned how to do it last time because I didn't know how either. In Math Excel, one of the questions has you come up with that. So I'll show you that today. And then exponential, we did. Does anyone remember what a is for exponential? So it's the initial amount, like whatever you start with. And then b is going to be the multiplier. Or it's like the growth or decay factor. If you're doing exponential growth or decay. Basically, the starting amount and then how it increases or decreases. Okay? Okay, if you have a table and your x's are going up by 1, this kind of tells you how you're going to decide what type of function it is. Typically what we do is we see if it's linear or exponential first, and if it's neither of them, then we just kind of like prove that it's quadratic, because quadratic's like a little more complicated. So a linear function is going to have an add or subtract pattern that's constant in the y values. So add or subtract pattern in the first difference. Exponential is going to have a multiplier divide pattern, and we always write it in terms of multiplication, so this is like times 2. And then if it's neither of those, like you can't see a constant pattern in the y values, then you want to bring it out to what we call the second differences. So the way that you do that is you just write down what you're adding or subtracting as you move through these numbers, and then you do it again, figure out what you're adding or subtracting as you move through those numbers, and that's where you're going to see the constant pattern. Okay, so I'll show you when we get to one like that. But so this is the like second difference is what you want to keep in mind. All right, come on. So first we're just going to plot points, and then based on the shape that we get, say what kind of function it is. So remember, when you're plotting points, it's left, right first for the x. Slope is the other way around. So 1, 3, you're going to go right 1 and then up 3 right here. 0, 0 is right at the origin.
Wait, you go up 1.
Right 1, up 3. So it's the opposite of how slope moves. Negative 3, 3 is going to be left 3 for negative 3 and then up 3. Negative 1 is going to be left 1, down 1. And then negative 2, 0 is going to be right on the x-axis. So since it decreases and then increases, what kind of function is this? Yeah, quadratic. Okay, and then for B, 0, 2 is on the y-axis. Negative 1, 4 is left 1, up 4. 1, 1 is right 1, up 1. And 2, 0.5 is right 2 and then up half a square. So this is it's like decreasing, it doesn't go back up. It's kind of leveling out, so what's that going to be? Yep, exponential, because it doesn't make a straight line. And then for C, negative 1, negative 2 is left 1, down 2. 0, negative 1 is at negative 1 on the y-axis. 1, 0 is at positive 1 on the x-axis. And then 3, 2 is right 3, up 2. So what kind is that going to make? Linear. Yeah, because it's a straight line. Any questions on that? Okay, when you're ready, you can do the next two. I hate when that happens.
It's like the water went down the wrong pipe.
Yeah, I hate that.
I was like, get on fours and all fours and someone will jump on your back. That'll save you. Wait, what's so goofy? Don't worry about it. It doesn't make any sense. What is it? It's quadratic because it's like a U. That's not normal. That's true though, but like that's not. Like, what the? I don't even think it's really like, you know? It's just like, it's just good. It's not music, Olivia. It's not here. This is probably at the freaking here. I'm gonna put it out for you. For you look so cute. It's
Okay, are you ready?
Yes.
Okay, so for the first one, you have 0, 0, 1, 1, negative 1, negative 0.5, 2, 3. So what kind is this?
It's exponential.
Exponential.
Wait, I did it wrong. Real. I know, I mean.
Yeah. Okay. Huh?
I just don't know where to put it in that little point.
Just halfway down a square.
I did it wrong though.
Okay, negative 2, 11, negative 1, 5, 0, 3, 1, 5. So what's that one going to be?
Quadratic.
Quadratic, yeah, because it goes down and then back up.
What the five? Yeah, Flynn. I think you got that. No, you literally. No. No, Allison.
Okay, are we good? Do we understand that?
Yes.
Okay. So now when we're looking at tables, as long as the x's are going up by 1, you're just going to look and see what the pattern is for the y values. So for this, you're going to check add, subtract, multiply, divide patterns. So what do we got here?
-4.
Yep, -4, and that continues all the way through.
-4. -4.
So since that is subtraction, what kind of function is this going to be?
Linear.
Linear, yep. And then I'm going to walk you guys through. I know it doesn't tell us to, but I'm going to show you guys how to find the equation for that because on Math Excel it might have you write the equation.
No. Essentially, what lessons is the best to focus on the test, or is it like all of them?
All of them. Yeah. Okay, so what is the standard form for linear?
Y equals
Yeah, y equals mx plus b. Okay, so the slope is the change in y over the change in x. The change in x is just 1. So how is the y changing?
-4.
Yep, so y equals negative 4x. And then remember your y-intercept is where x is what number?
So -1.
0. So you're looking for where x is 0. And that tells you that that's your y-intercept. So it's going to be -3. Does that make sense?
Yeah.
So slope is how this pattern, and the y-intercept is where x is 0. Got it? Okay, so now for this one, do we have a constant add or subtract pattern?
No.
No. What about multiply, divide?
Divide. Multiply.
Are we multiplying by the same thing each time?
Yeah. No.
No. So if you can't see an add, subtract, multiply, or divide pattern, then it's kind of decided tentatively that it's quadratic, and you have to prove it, okay? So the way that you do that is you're going to write down what you're adding or subtracting as you move down this list. So going from 0 to negative 0.25, what am I doing?
Why not negative 2.5?
No, yeah, just, what am I doing to get from this to this?
Oh. Negative 0.
Yep. Minus 0.25. Okay, what about from that to that? Yep, subtracting 0.75. Okay, what about from this to this? Yep, subtracting 1.25, right? 25, and then from this to this. Yep, subtracting 1.75. Okay, then you're going to do this again with these numbers, and those should be the same. So going from here to here, what am I doing? Subtracting 0.5, right? What about from here to here? Yep, subtracting 0.5 from here to here. Yep, so those are called the second differences. Okay? So it's like how the changes are changing. So that's how you prove that this is quadratic.
Wait, how?
By taking it out to the second differences.
Oh,
This.
if it's like even.
If these end up being the same.
Yeah.
Yeah.
That's quadratic.
Yep. Okay. And then standard form of a quadratic is y equals ax squared plus bx plus c, right? Okay, I'm going to show you guys how to put that together based on a table. I just learned this last night, and it's actually way easier than I thought it was going to be.
Okay. Will this be on our test?
No, it's just for Math Excel. They might have you write the equation, just so you guys know how to do it.
Okay.
So the a is this number divided by 2. So what's negative 0.5 divided by 2? Yep, negative 0.25. So that's how you figure out what a is. So far we have y equals negative 0.25x squared. Your c is the next easiest one to find because c is your y-intercept. So what would our y-intercept be when x is 0? Yep, so 0. So we're just not going to have a c. Okay, and then to find b, huh? A would be the first one.
That means C is like
The last one.
no, like the first one on the table.
No, just wherever x is 0.
Okay.
So the y-intercept. Okay, then the way you find b is you basically like take one of your points and plug in the x and see what you get, and then see like how much different that number is from like what it says the y is supposed to be, and then you can figure out how much more you have to add on to the equation. Okay, so I usually like to use 1 because it's just the easiest to like plug in for x. So if I plug in 1 for the x, what's 1 squared? 1, right? Times negative 0.25? Negative 0.25. And then see how on the table at 1 it says negative 0.25? So that tells you that you're already getting the answer you need to, so you don't need to add anything so b would just be 0 also. You wouldn't have anything else, this would just be your equation.
Wait, how do you know? Because how do you know x is 1?
I just pick one of these points. You just pick any point you want, plug it in, plug in the x, and see what you get for the y, and like compare it to what it says you're supposed to get. So let's say like I got 3 for the y whenever I plugged in the point, but on the table it says it's supposed to be 5. Then I know I need to add a 2x, like plus 2x, because you need to have 2 more. That's why I use 1, because then you could just, whatever, how much more it is just what b is. Does that kind of make sense? Okay, so, hold on. So let me rephrase this. So let's say, I always like to plug in 1 because let's say the table right here said that this was supposed to be 5 for y. But let's say when I plugged in 1, I only got 3 for y. Then see how the difference between the 3 and the 5 I'm supposed to get is 2?
So it's supposed to be 1 for y?
No, I always, like wherever x is 1, that's the point that I plug in to test it.
Yeah, and what's it supposed to equal?
It's supposed to equal what the y says.
Oh, negative.
Yeah.
Oh, okay.
And it already equaled that, so that's why we didn't have anything else. But let's say it was supposed to equal, like,
5.
yeah, then you know that like you have to add a 0.05x or something because of the difference in amount. Yeah. But you guys don't need to know that. I literally never learned that in any math class. Like there's no time that you guys would need to do that except for the random math Excel if it comes up. Okay. All right. Good. Okay, so you guys do the bottom ones to this one. So say what kind it is and try to put together the equation.
I'm scared. How do you know if it's exponential? If it's multiplying or dividing? Yeah.
If it's multiplying or divided pattern, yeah.
Oh, okay, thank you. No. They're actually good. Yeah, you did a couple of these. It was relaxing. It was relaxing. Well, I didn't really try it, but
You watch them just like lay down.
the end of the at the end
What?
of I mean,
Literally yesterday we had to like
Guys.
open our
Guys, are you done with this? Did you write the equation also? So we put it on the front page.
If it's multiplying,
No.
what's it go?
Then that's what b is. Whatever you're multiplying by.
It's 2.
It, like,
So-
So what equation do you use?
It's on the front page. The y equals a times b to the x. So what kind of function was this, guys?
Exponential.
Y, what's it multiplying by each time?
2.
So if it's a multiplier divide pattern, it's exponential, guys. Okay, and then standard form for exponential is y equals a times b to the x power. A is your starting value. So in other words, your y-intercept, which is what?
0. It's
0.5.
Was 0, comma 1. So 1 is your starting amount. Okay, so 1. And then b is what you're multiplying by each time.
Wait, how come you do y?
Hmm?
Like for a, y equals a. Like on that one.
It's just that's just like what it is. Yeah, so it's always your starting amount and then what you're multiplying by, or increasing or decreasing by. So this one you could just say y equals 2 to the x power. You don't have to have the 1, but we're to keep it. Okay, good there?
Yeah.
Okay. Last thing we're going to do is graphing absolute value functions. So just like the one we did in the warm-up, but we're going to basically be taking that one and moving it. So there's 3 ways that your graph changes. The first way is with A, which is in front of the absolute value bars. The job of A is to stretch the graph, shrink the graph, basically change the slope from up 1 over 1 in both directions, or to flip the graph upside down. We are not going to be doing any stretches and shrinks in this class. You guys will do that in Algebra 3, 4. So the only thing that we are going to focus on is that if it's negative, it reflects over the x-axis, meaning it flips upside down. To look like this. If it's negative. Okay? So that's A. Which is in front. Okay, H is the value that's being added or subtracted on the inside of the absolute value bars right there. It starts out negative, so it's always the opposite of what you think it's going to be. It goes left and right, so if it's negative, it goes to the right, and positive goes to the left. And then K is whatever is being added or subtracted after the absolute value bars at the end. And that is your up and down mover. And that one does what you think it's going to do. If it's negative, it goes down. Positive is up. Negative is down. Okay, so for this one, A, what is that minus 2 going to do? So you have to ask yourself if that's an H or a K. If it's after the absolute value, is it an H or a K?
K.
It's a K, so how's that going to move?
It's gonna go going down.
Yep, down 2. Rio,
Sorry, I'm putting things for.
write this down, please. Okay, then the plus 5 on the inside is an H, so what's that going to move?
Right.
Mm-mm.
Left.
Yep, left 5. The H is the one that's backwards.
You know the different letters.
You guys remember?
H is on H is on the inside, K is on the outside. The H is with the X in the absolute value, K is after. So inside the absolute value is left and right, after the absolute value is up and down.
Inside.
I think I actually got it.
Okay.
Oh, so it's the opposite of plus
For
five.
H, yeah.
It's on my screen.
So if there's something inside the absolute value, then it's H. If it's outside, then it's K.
Oh yeah, why is it being too blind?
Yeah, why? I yelled at him to go to like.
That's the absolute value of.
Did you hear when he
Those are absolute value bars.
It's annoying when you guys say no. Did you hear what it said? Then just don't listen to us. We're like, literally no one cares.
Oh,
Steve. Okay, I honestly, but she does the same thing to us. That's why I did it to her. Like, it was
Oh, I got it.
If she was anybody
It's
else, I
whatever
probably wouldn't
was
say
on the end.
anything, but she has issues.
Oh, so. Oh.
You know. I love Kate. I feel like she kind of like she's.
Okay, what is the movements for, guys? What are the movements for A?
Up 3.
Yeah, up
And
3.
right 1.
Yes. Right 1. Okay, good. So now we're in a graph. So I'm going to show you what the parent function looks like, and we're going to shift it, but then you're not going to use the parent function anymore, okay?
Nope, I am.
So the parent function is the one that you guys graphed in the warm-up. So it's y equals the absolute value of x. And that is starting at 0, 0, and then just up 1 over 1 in both directions.
Do we have to remember all these things or not?
Yes. And this is easy to remember.
F3 right 4.
No.
What the?
Oh, we're not doing that yet. This is the parent one. That hasn't been changed. So the starting one.
So what is it?
It's just starting at 0, 0, and then it's just up 1 over 1 in both directions. It's the one you did in the warm-up.
So you always do this?
You're not actually gonna write this always, but just so like a visual, since this is the first time you guys are doing this. But that's like always the starting one. That's the one that we're moving with these movements. Okay. Okay, so let's list out what the transformations are for this one. So what does the negative in front mean?
F3 right 3.
Hold on, wait. What's the negative in front mean?
It's a negative.
Right?
X flips.
Yep, so it reflects. It reflects over the x-axis, meaning it flips upside down. Okay? Okay, this one, h is negative 3, so what's that mean?
How is that negative?
Because it's an x minus h, so it's technically a negative that was plugged in. This is the value that's like not the opposite.
So down 3.
Nope, it's left, right. So what's x plus 3 mean? Yep, left 3. That's why it's left 3, because the h is technically the opposite number. And then what's the minus 4 for k? Yep, down 4. So just take your vertex and go left 3, down 4. Hold on.
What?
Can you just say I use Selena's table for like 2 seconds? If I have to eat, then I sit there. Yeah, it's rare, so.
You know you're always
Okay. All right, I'm just making sure I was right. Okay, so guys, the reflect happens first. So you're going to move left 3, down 4. And that's going to be where your new vertex is, right here, right?
Yes, ma'am.
And then you're just going to flip it to where it's upside down, but it's still going to have the same slope. So it's going to go like this.
Is this question on the test?
Yes.
Oh my god, this is so confusing.
yeah, this is really confusing.
Guys, you literally just move it left 3, down 4, and then flip the graph.
What do you mean flip it?
Yeah.
Like it just goes upside down.
I got it.
So just like down.
What?
Yep.
The right one.
Yeah.
Is it just 1, 1?
Yeah, it's always going to be 1, 1. Yeah, it's, that'll change in Algebra 3, 4, but right now we're always doing 1, 1. And it only flips upside down because you had that negative in front of the absolute value. That's what did that.
So when we don't, what happens?
Then you just keep right side up. Just move the vertex and just up like normal. So you don't need to graph the parent function. Just move the vertex and then just draw
so
the
what's A
v.
if you don't have the-
Just 1. Yeah, so then it just doesn't do anything. If you don't have the negative in front, that's the only thing you would have in front for right now. If you don't have anything, then just skip it.
Well, we
Is
always,
Does the H come first? Or
H is on the inside. And then K is at the end.
then why'd you do H on the inside?
That's because that is. H is on the inside and then K is at the end. Yeah.
I'm confused about the H part. So why is it negative?
So the reason why this is going left 3 is because h is negative 3. Because it's the normal formula is x minus h. So the only way that turned to plus 3 is if it was a negative 3 that was plugged in with the minus. Does that make sense? Okay.
Can you see mine? Don't look at mine.
Yeah.
Should I do it right?
Right 2.
Oh, okay.
Otherwise, yeah.
Okay. So K is on the outside and H is on the inside.
H is on the inside. You just don't have a 3 at all. And that's
So H is on the inside, K is on the outside.
okay, so for this one, guys, we don't have an A, so nothing's going to happen there. What's the minus 2 tell us we're going to do? Yeah, we're going to write 2. And then what about the plus 1? Yep, up 1. So just move your vertex from the origin, right 2 up 1. And then just draw your V from there.
Wait, when are we supposed to draw on the original?
You don't have to. Yeah, once you're good to skip it, then skip it. I just wanted to do it on the first one so you guys could see. So that's what your X gonna look like. Got it? Any questions? Okay, go ahead and do the lesson check real quick. Then you just wouldn't move left or right.
So is it just up 5? Where could it just get up 5?
I just put my
I thought it down 5. What? No, it was the negative. But there's a negative in front of it. Yeah, then you flip it. Oh, that graphs for that one? So that just means it goes down when you flip it. It doesn't change the numbers. Yeah.
It's it just like keep the vertex where it is, and then instead of going up, just go down.
You always go up with your negative.
Yeah.
What do you say? I thought you tickle me.
I'll listen.
What?
No.
I do.
Oh my god, my mother brings home. Sorry. Why? Probably
Are we done with the lesson check, guys? Yes?
Yes.
Okay. For the first one, let me grab these real quick. 0, 11, 1, 5, 2, 3, 3, 5, 4, 11. Okay, what's the first one? Guys,
Quadratic.
yep, quadratic.
Oh, that's for that?
Hmm.
Wait, I should have put.
Okay, which type of function best models the data? So look at the y's. What's happening with the y's?
So,
What's
you're
happening?
multiplying two.
Well, this is the same one that we did. That's dumb. Yep, so exponential.
Exponential is multiplying, right?
Multiplying or dividing, yeah.
And then you use
Adding or subtracting. Yep. And then the transformation, so what does the negative do?
It's down 5.
No, yeah, but what's this?
It flips it.
Yep, so reflects. And then down 5.
Thank God.
I thought it was, oh, it was
Talk
less.
to my mom
I
about
thought it was
that, so
less.
I know that was
No, it's on the inside. That's the value, yeah. All right, we good?
Yeah.
Cool. That's the last lesson.